Hi, I'm Phil, and today I'm going to explore how music can be played on M5Stack computers. So the overall objective is that this is a topic in STEM. In fact, at the moment, for the Blacktown and Parramatta Libraries, we're running a series of topics on microbit and music. And now it's my turn to have a look at the M5Stack computer. So the hardware, I'm going to use both the M5StickC and also the Fire. And for software, I'm going to use UIFlow. And as long as I'm using the speaker, there's some statements that are available to me to play both music and also to play sound. Okay, so the projects that I've already been looking at include the electronic organ, and that comes as a demonstration on the M5StickC computer. As long as you add the speaker hat on the end, you've got a complete electronic organ, which uses the accelerometer on the M5StickC. And I'm going to use the boomwackers color code. So it originally started off with plastic tubes, and they're all color coded, and the colors go through the musical scale. So you can see the C major scale here from C up to C, an octave above, and it's all color coded. And I'm going to duplicate that on the M5Stack Fire computer. So let's have a look at it. So we're going to use Makey. So this is the arrangement. This is what it looks like on my desktop. And you can see over here, I've got banana clips that are connected by wires to a Makey. So there's the Makey on the bottom, and that's connected by a Grove cable to the Fire computer. So you can see the Fire right on top, and the colors. So when I press B over here with my fingers, the color code for B comes up, and I can select any octave from 1 to 8, and the Fire computer plays that note on its internal speaker. So if we actually have a look at what I'm trying to achieve, I want to use the M5Stack Makey Unit to make either a fruit or a Lego piano. In my case here, the one I'm illustrating is a Lego piano, and I'm using electric paint to paint from the banana clips to Lego blocks. And the Lego blocks also comply with the boomwackers color code. And I want to be able to select any octave that I want to. So I'm not just restricted to the blocks on the Lego board. So to select that octave, I increase an octave by pressing button A on Fire, or decrease an octave by pressing button C. And I can reset to the default octave, which is number 4, by pressing button C. And for hardware, I'm using the Fire computer, and it's got a Lego base, and it's powered with a powerful ESP32 with plenty of RAM, which is a lot better than just using a microbit. There's a lot more RAM available, and you hardly ever run out of space on that. And I'm also going to use the unit from M5Stack called the 16-key capacitive touch unit. And it has its own Arduino 328 on board. So it handles the processing and communicates with the Fire computer via a Grow connection, which is an I to C communications. And I'm using Lego color bricks for the base. And I also use Technique parts to connect the Fire computer to the Lego base. So for software, I'm using UIFlow, and I paint my user interface on the screen. So I've got various labels, and I've got rectangles, and I've identified the program right on the top on the title bar. So you can see it here. We might actually walk through that in the next segment. We'll walk through the software. Execution-wise, it worked out quite well, and I achieved my results. So hop along to M5Stack if you want to see the Fire. Unfortunately, the 16-key capacitive touch unit is no longer supported by M5Stack, even though it's a very useful unit for STEM education. And we'll have a look at the software next. So here we have the UIFlow IDE on my Chrome browser. So over here we can paint the user interface, and we can do this by selecting title and just drag that onto the screen, and we can give it the program name. So it could be called music, say, and we can drag various labels down. So we bring a label down, and here we're going to identify the name of the musical note. So I'll just increase that, and I'm bringing down a rectangle, which is this one here, and we can make it bigger, so you can see the size of it. So let's make the width 120, and the height can be, say, 80. So you can see that we can create shapes, and we can access these in our program. And so our user interface allows us to create events. Let's see if we can make that a little bit bigger. And if we wanted to access the labels, we just simply drag that label across, and we can give it a name in here, and that will put the text onto our label 0. And for hardware-wise, we go to the speaker, and we use either the frequency, or we could use the musical scale and play that. Now, I prefer this one because it gives you the ability to program both the duration and the frequency. So let's have a look. We'll go and open up our program and just see what it looks like. And here we are. We've got our user interface over here with label 1 to identify the frequency note, and the other ones identify the status of our octave. So we can increase the octave and show what the octave is on label 5. And this rectangular block will paint the color of the boomwackers color for the musical note. And we show what that note is on label 1. So if you look at startup, we actually create a list or an array that has all the frequencies starting off with C1, and this is in hertz. So we go from C, D, E, F, G, all the way through back to C and D again. And we access this array, which is called frequency in the scale. We access that with the Makey code, which is selected when we touch the particular Makey pin. And we start off with the setting up the variables, the octave, the minimum, maximum, and the default is 4. And in the loop, we go and grab the value of the current Makey. And depending on the value of the Makey, we show that value, And we also show the current octave number. And if the Makey value is greater than the no note value, we display the note and we play that note. So we've got a couple of functions there. In displaying note, depending on the value of the Makey, we then select the color from the boomwackers range of colors onto our rectangle. And we show on the bottom, we show that on label 1 what that Makey value is. And interesting, we use that Makey value and index it to a over here we've got a string, and we select a particular character to show what the musical note is. When we press button A, we increase the octave, and when it gets to a maximum, it just stays there. And similarly with B, we decrease it, and with C, we just set the octave to the default level. And now what's interesting, the other algorithm, which is a function here, play the note, is again using the list frequency in the scale and multiplying that by the octave to then rounds that up and then plays that frequency on the M5Stack Fire computer. And that's the software. So not a lot to it. It's quite compact. It's using arrays and indexing for both getting the correct color and the correct note, depending on the octave and the key that you select with the Makey. And that's the software for our Makey music program on the M5Stack Fire computer.
Here we have two computer-based musical instruments, and the computer in each case is the ESP32, and here it's packaged on the left here in a M5Stack Fire computer, and on the right we're using a M5StickC computer. And this computer here is connected via Grow cable to a Makey unit, which can sense when someone touches one of these crocodile connectors. And the crocodile connectors are connected via electric paint to color-coded Lego. So when you press one of the keys, it will show the boomwackers color for the music note that I press. And that's the fire-based Makey musical instrument. Now on the right we have a theremin computer, or a theremin, which has a laser. So there's a laser on the front, and it can detect how far my hand is away, and it will then play on the piano keyboard the musical note corresponding to where the piano currently is. And it's using the boomwackers color coding system. So it goes from red, orange, yellow, all the way through back to red again, which represents the note C on the musical scale. And that's the two musical instruments based on M5Stack computers. The colours here are boomwackers color-coded. So we go from C, D, E, F, G, A, B, C, and those colours are also coded onto the screen of the Fire computer. So when we press different notes over here, we go to C, it will play the note C on the Fire computer, and we go through the scale. We get orange, then we go to right through the scale. We've got G, A, B, C, and D. So we have a Makey with the ESP32, and we can change the octave by pressing button A. We're on octave C, A4 at the moment. We can make that go A5, and we go up an octave. And the top octave is 8. And we can go down an octave. So we'll go down to 3. Or we can go down to 2. Or even 1. And that's the color coding on the M5Stack Fire computer.